Hello students, today we are going to do the experiment in which we are going to determine percentage purity of NaCl and amount of sodium present in the given sample of NaCl. The experiment requires 0.05 normal NaOH and a column containing a cation exchange resin charged with H plus ions. Here we are using the synthetic ion exchange of the type cation exchanger Amberlite IR 120 having solid polymeric nature, which is activated by dipping it into 2 normal SCl for 5 to 6 hours, and after activation for 5 to 6 hours it is washed with distilled water till it neutrals to the blue litmus paper. The slurry soap prepared in the distilled water is transferred into a 50 centimeter cube of burette to get a resin bed of 20 centimeter in height. To settle a resin in the burette, a cotton wad is inserted into the burette till it reaches at the bottom of the burette. After which, the slurry of resin prepared is added into the burette to get the resin bed of 25 to 30 centimeter in height. Meanwhile, the burette is tapped to remove the air bubbles from the resin bed. The tapping is continued to remove air bubbles in the resin bed. In this way, we are getting a cation exchange resin bed of Amberlite IR 120 of 25 centimeter height. Given sample of NaCl is first dissolved in a minimum quantity of distilled water in the beaker. After dissolution, transfer the solution in 100 centimeter cube of standard measuring flask and dilute it with distilled water up to the mark. Adjust the flow rate of the column at the rate of 5 ml per minute, so that the effluent which coming out of the column is 5 ml per minute. To pipette out 10 ml of diluted NaCl solution, transfer the diluted solution in the beaker. Pipette out 10 ml of diluted NaCl sample solution. Transfer it in another beaker. And add into the column to allow the exchange between Na plus and H plus ions in the resin column. Collect the effluent in 250 ml standard measuring flask by passing 100 ml distilled water. As all the effluent is collected in 250 ml standard measuring flask, close the stopcock so that the bed level should be, water level should be above the resin bed. Dilute the content of the flask up to the mark by using distilled water. Pipette out the diluted collected effluent into the conical flask. Pipette out 25 ml of the diluted effluent. Add 2 to 3 drops of phenolphthalein indicator to the content and titrate it against 0.05 normal NaOH till the pink color appears. So titrate the 25 ml of diluted effluent solution against NaOH till permanent pink color appears. Note down the burette readings. Take 2 more readings to get constant burette reading. The CBR is 6.5 centimeter cube. Do the standardization of 0.05 normal NaOH by preparing 0.1 normal succinic acid solution and note down the burette readings. And by taking constant burette reading, calculate
the amount, calculate the normality of given NaOH solution. The standard normality of given NaOH solution is 0.045 normal. Then calculate the amount of Na plus and percentage purity of NaCl of the given sample by using the constant burette reading. Calculate the amount of sodium by stoichiometry. 1 mole of NaCl is equivalent to 1 mole of Na plus and 1 mole of H plus as well as 1 mole of NaOH, and therefore the given sample solution after calculation contains 0.6727 gram of sodium and 1.711 gram of NaCl. The weight of the given sample is 2 gram, and therefore percentage purity of given NaCl sample is 85.55. The percentage error found to be 0.64, and the final results are the normality of given NaOH solution is 0.045 normal. The 25 ml of the diluted effluent solution required 6.5 cm³ of NaOH. The amount of sodium present is 0.6727 gram. The amount of NaCl present is 1.711 gram, and the percentage purity of NaCl is 85.55%, whereas the percentage error involved is 0.64%. That's all. Thank you.